All right, welcome back for another deep dive. Today we're taking a look at something that I think is really, really at the core of philosophical inquiry. And I know being a philosopher yourself, are probably super interested in this idea of the unity of science.
Yeah. I mean, this is one of those questions that has occupied philosophers and scientists for centuries, right? Like, how does it all fit together?
Exactly, exactly. And thankfully, we have a really, really comprehensive overview of this whole topic. We're going to be referencing and working with the IRI on unity of science from the Stanford Encyclopedia of Philosophy.
Yeah, the SAP, it's a great resource.
Oh, yeah, for sure. A really great resource. And I think our aim today is not to kind of, come up with like a single definition of what unity of science is. Because as you can imagine, it's a very complicated topic. It's been discussed and debated for, like we were saying, for a long time. So we want to get a sense of the history of these discussions.
Yeah, like how philosophers and scientists have thought about this, the different forms that unity might take, or maybe it doesn't take any particular form.
Yeah. And why are these debates even important?
Right. And I think, as we kind of go through this and look at the different historical perspectives, look at kind of the ontological, epistemological questions, even looking at arguments for disunity and pluralism, we're really engaging with some pretty fundamental
Oh,
questions
for sure.
about the nature of reality. Like, what is the world really like?
Now we know it. How can we even know it?
Right. And, hopefully by the end, we'll be able to tease out some of these connections.
Yeah. Okay, so maybe to kind of unpack all of this a little bit,
Hmm.
it's helpful to look back and see where this whole idea of unity even began.
Yeah.
And it turns out that it goes way back to pre-Socratic Greek cosmology.
Yeah.
You have that really enduring puzzle of the one and the many, right?
Yeah, I mean, it's fascinating how, these early thinkers were already kind of grappling with these underlying principles of the cosmos,
Mm.
right? And implicitly, they were also raising questions about the unity of knowledge, right? Like, how do we
Yeah.
know this stuff?
Yeah.
So, you had Parmenides arguing for this single unchanging reality, and then you have Heraclitus who thought, no, everything's in constant flux.
Right, totally different.
Right. And then you have thinkers like Empedocles with the four elements, Democritus with atoms, Pythagoras obsessed with numbers, Plato with the forms, and then Aristotle with his categories.
Right, right. I mean, I'm amazing how this question of unity is sort of implicit even in these early attempts to understand the fundamental nature of reality, right?
Yeah, exactly. It's not just about, what is the world made of, but it's kind of how do all these different accounts
Right.
fit together? How do they relate to each other? How do we get a coherent picture?
Yeah, yeah. And Plato actually explicitly asks this question in this office, right?
Mhm.
He says, knowledge also is surely one.
Right.
So he's acknowledging all the different arts and forms of knowledge.
Yeah.
But then he's raising this question of, well, but how is it all connected?
Right. It's like you're looking at the branches of a tree,
Yeah.
and then you start to think, okay, what about the trunk that's connecting all these?
Exactly.
Yeah.
Exactly. And Aristotle, in On the Heavens, he kind of hints at this sort of hierarchical structure.
Mhm.
He talks about how metaphysics provides knowledge of the underlying kind of being. So it's sort of suggesting that there's this kind of unifying foundation for all other forms of knowledge.
Yeah, there's a kind of a foundationalism there.
Yeah, exactly,
Yeah.
exactly. Okay, so let's jump forward a few centuries now,
Yeah.
and our source points to a really, really significant influence of Christian monotheism. I guess it's kind of a natural connection, right? If you believe in one God who created a consistent universe,
Right.
that kind of leads to the idea that there must be some sort of unified order, some sort of, you know, divine laws that govern everything.
Yeah, exactly. So this theological framework, it really had a profound impact on how knowledge was organized and conceived of,
Yeah.
right?
Yeah.
So, think about the kind of encyclopedic efforts of this time, like Isidore of Seville
Right.
with the etymologies. These weren't just random collections of facts. They were trying to present this kind of unified picture
Yeah.
of a divinely created and ordered world. So it's like putting together the pieces of a puzzle,
Yeah.
and you have this kind of grand design in mind.
Yeah, yeah. And then you have thinkers like Ramon Lull with, his really intricate diagrams
Right.
and this idea of a mathicist universalist, this
Mhm.
concept of a universal symbolic system that could, in theory, unlock all knowledge
Right.
and even bridge cultural divides, which is
Ambitious.
very ambitious,
Yeah.
very powerful vision of unification.
Yeah. And then Petrus Ramus, with his focus on classifying all the arts and sciences into a clear structure,
Right.
also contributed to this ideal of a well-ordered body of knowledge.
Yeah, yeah. I mean, these efforts, even though they might seem a little bit, maybe outdated to us now,
Sure.
they really reflect this deep desire to kind of demonstrate that there's this underlying unity
Yeah.
by categorizing all these diverse aspects of learning.
Yeah, like there has to be some order there.
Yeah, exactly. Exactly. Okay, so here's where things start to shift a little bit, I think, with the emergence of a really distinct scientific tradition,
Right.
right? And the focus starts to move more towards this idea of a privileged method, right?
Yeah.
And often this method is inspired by the logical rigor of Euclidean geometry.
Right. So in the late 16th century, we have, Francis Bacon, who kind of envisions a unified science
Right.
arising from this kind of systematic collection and organization of empirical facts.
Right.
Right. And these facts, they would be structured in this kind of hierarchical way
Yeah.
to reveal increasingly general principles.
Yeah.
Right. It's interesting, he also linked different scientific disciplines to specific human cognitive faculties.
Huh. Interesting.
Right. So he thought, for instance, history corresponds to memory, poetry to imagination,
Oh, wow.
philosophy to reason. So there was another way in which knowledge could be unified through our own minds, through our cognitive faculties.
Yeah, yeah. And then you have Galileo, right, who famously stated that the book of nature is written in the language of mathematics.
Right.
With, this core set of measurable, objective primary qualities.
Right.
I mean, that's a really, really potent image of unity, like the
Yeah.
entire natural world,
Yeah.
understandable through this one precise language.
Yeah, and we shouldn't overlook the continued influence of theological ideas during this time period.
Oh, for sure. Yeah.
Right. The belief in a single creator, God, often provided the philosophical backdrop for the search for this kind of unified
Right.
scientific understanding of that creation. So, by the 17th century, we have the rise of mechanical philosophy, with figures like Descartes and
Right.
Newton,
Yeah.
and they offered these very promising frameworks for unifying knowledge. So the idea was, it's all based on these fundamental concepts and laws of mechanics.
Right.
Right. And even later, when Newtonian physics, faced certain challenges, we have ideas like ether mechanics and,
Right.
and energy physics that stepped in to try to maintain that unifying role.
Right. Right. So it seems like the desire for this kind of unifying principle, this unifying framework is really persistent
Persistent.
throughout this period.
Absolutely.
Yeah. Okay, so let's move into the Enlightenment now. This is, this period where there's this huge emphasis on reason.
Right.
And I think the idea of unity takes on a slightly different flavor here.
Yeah. So particularly with the rationalists like
Yeah.
Descartes and Leibniz, the focus is really on the power of human reason
Yeah.
as the unifying force, right?
Right.
So they imagine this universal system of categories, of ideas,
Right.
a mathesis universalis, right? So Descartes, famously used this analogy of a tree of knowledge,
Right.
right? With metaphysics as the roots, physics as the trunk, and then all the other sciences as the branches.
Right.
Right. So all connected, all deriving from this central source.
Right.
It's like saying that all knowledge, grows from the same fundamental ground.
Yeah. 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 And Leibniz, with his project for a characteristica universalis, this kind of symbolic language
Right.
that would make, in theory, all knowledge demonstrative, right?
Mhm.
And you could resolve disagreements through logical calculation. That's quite ambitious.
Yeah. Yeah, absolutely. The the ultimate aspiration for this kind of formal unification, I think. And for both Descartes and Leibniz, right, the idea was to ground their physics and even their ideas about life in metaphysics.
Right.
Right. So there's this interesting tension between the two. However, it's important to contrast that with Newton, who, while appreciating the mathematical structure of knowledge, he intended his natural philosophy to be autonomous from a kind of comprehensive system of philosophy.
Right. Right.
Right. So for Newton, the emphasis is on empirical investigation
Yeah.
within this kind of mathematical framework.
So not necessarily deriving, the laws of physics
Yeah.
from some grand metaphysical scheme. It's more like let's look at the world and see,
See how it works.
how these mathematical principles apply.
Exactly.
Yeah.
Yeah.
Okay, so the Enlightenment as a whole, our source points out, really, really embraced this conviction in the unity of science.
Right. Right, and the universality of reason.
Yeah.
I mean, think about Diderot and D'Alembert's Encyclopedia.
Oh, yeah. Monumental work, right? I mean, that was explicitly designed to showcase the interconnectedness of human knowledge.
Yeah, yeah,
Right. And
yeah.
and even their classification of the disciplines was based on the human faculties, right?
Right.
So it reflects this unifying ambition, right?
Yeah.
Diderot himself, he actually said that encyclopedia means the linkage of the sciences. So whereas Leibniz was focusing on logical connections, Diderot and D'Alembert, they emphasized a kind of unity of subject matter,
Right.
right? And they used all these cross-references
Right.
to highlight these connections.
Yeah, yeah. I mean, it's really interesting how this ideal of unity is being kind of manifested in these different ways, right?
Yeah.
So you have the rationalists focusing on the power of reason.
Right.
You have the encyclopedists focusing on
Connections between subjects.
the interconnectedness of different fields.
Yeah. Okay, so this kind of culminates in the German Enlightenment, I guess, with Kant,
Right.
who offers this really, really distinctive take on the unity of science.
Yeah, yeah. So for Kant, right, unity is not something we kind of discover out there in the world.
Right.
It's imposed by the unifying a priori structure of our own understanding,
Right.
right? So our concepts, our principles, reason itself, right?
Yeah.
So nature, as we experience it, is already kind of shaped by these universal mental frameworks.
Right.
So the unity of science arises from the way we organize our experiences
Yeah.
according to these principles.
Yeah, yeah. I mean, that's a big, big, big difference from a big shift from saying that the unity is somehow out there in the world,
Right.
and we're just discovering. He's saying, no, it's in us.
Yeah.
It's in the way
That's how we
organize that we think.
Yeah, yeah.
Yeah. So he admired Newton, obviously, right? But he had some interesting reservations about other fields, like chemistry and biology.
Right, right. So for Kant, genuine science required mathematization and a priori universal laws.
Right.
Right. So he viewed chemistry as more of a systematic art based on empirical generalizations,
Okay.
but it lacked that a priori foundation of physics and mathematics.
Okay. So it wasn't quite a real science for him.
Yeah. And he famously argued that biology, with its reliance on teleological explanations, right?
Right.
Explanations in terms of final causes,
Yeah.
that it couldn't be fully reduced to mechanistic principles.
Wow.
So for Kant, unity was more of a regulative principle.
Okay.
Right? This kind of ideal guiding scientific inquiry
Right.
towards a complete and systematic understanding of the empirical world.
Yeah. Yeah. So it's not necessarily something that's fully achievable,
Right.
but it's something that we're striving for.
Yeah, it's the goal.
Yeah. Yeah. Okay, so Kant essentially shifting the ground of unity, right?
Yeah.
From the external world to our own cognitive architecture, to the way that we try to strive for systematic knowledge.
Right, right.
Yeah. And this kind of lays the groundwork, it seems, for this whole German intellectual tradition that follows,
Yeah.
where, the concepts of Weltanschauung worldview and Weltbild world picture become really, really central.
Right.
And this kind of further solidifies this ideal of the unified science as providing this kind of comprehensive understanding of reality.
Yeah, like a grand synthesis.
Yeah, exactly. And this leads to some really fascinating debates, especially concerning the distinction between the natural sciences, the Naturwissenschaften, and the cultural and social sciences, the Geisteswissenschaft.
Right, right. So you have, thinkers like Windelband, Rickert, Dilthey, and later Weber,
Yeah.
who are all grappling with whether, these two types of science, with their fundamental differences in subject matter and aims, require fundamentally different methodologies. So their emphasis on the historical and cultural specificity of human phenomena, right?
Right.
Which builds on Kant's focus on concepts.
Yeah.
Led to this idea that, okay, so natural sciences, they aim for general laws
Right.
about these kind of abstract entities, whereas the human sciences, they study unique individuals.
Right.
And they require this interpretive understanding, Weber's Verstehen, based on values and lived experience.
Right. So there's this real tension there between
Yeah.
trying to find this unified methodology,
Right.
and recognizing that there might be these fundamental differences
In what we're studying.
in the objects of
Right.
study.
Yeah. Yeah.
And meanwhile, within the natural sciences themselves, you have figures like Mach and Planck who are offering these kind of contrasting visions of a unified scientific world picture.
Right, right. I mean, it's interesting to see this tension between, Mach's perspective, which saw unity as a kind of adaptive,
Yeah.
economical way of organizing our sensations,
Okay.
right, based on evolutionary principles,
Right.
and Planck's more realist view,
Yeah.
which held that, science is progressively uncovering a complete and objective truth about the physical world.
Right, right.
Right, particularly through, thermodynamics and so on. So so these different perspectives offer alternative ways to conceive of what unity we're actually after.
Right, right. So is it a matter of, convenience and how we organize our experiences,
Right.
or is there this kind of, objective truth out there
Objective truth.
that we're slowly approaching?
Right, yeah.
Okay, so then in the early 20th century, you see this real surge of interest in the idea of unified knowledge.
Yeah, yeah, the monistic century, they called it.
Yeah, yeah.
I mean, figures like Ernst Haeckel and Wilhelm Ostwald were very prominent. They were proponents of this. You
Yeah.
see these international congresses dedicated to the unity of science,
Right.
manifestos, advocating for these comprehensive worldviews signed by leading scientists,
Mhm.
Einstein and so on. And there are numerous publications that are explicitly addressing this concept,
Yeah.
right? So it was a period where this ideal of a unified understanding of the world
Yeah.
held considerable sway.
Yeah, yeah. But this German tradition, this kind of German way of thinking about unity wasn't isolated, right? Our source points out its opposition to the empiricist views of people like Hume, Comte, and Mill.
Yeah, yeah. So these empiricists, right, drawing on the legacy of Bacon,
Right.
often drew parallels between the methods and concepts of the moral and social sciences on the one hand and the natural sciences on the other.
Okay.
Right. So Comte, with his encyclopedic law, right, proposed this hierarchical ordering of disciplines based on their generality and complexity, right? So you have, mathematics at the bottom, then astronomy, then physics, chemistry, biology, and then sociology at the top.
Okay.
Right. But Mill, he emphasized the diversity of methodologies
Right.
across different scientific fields and questioned whether we should impose a single unified standard.
Right, right. So there's this real tension even within empiricism
Yeah,
between, Comte saying, okay, there's this hierarchy,
yeah.
and Mill saying, well, no, we need to be sensitive to these
Use of
differences.
differences.
Yeah,
Right.
right.
Yeah.
Yeah.
Okay, so this kind of sets the stage for these 19th century positivist movements,
Yeah.
which were very, very concerned with trying to establish order and unity within knowledge, right?
Right, right. So you have thinkers like Comte, Mill, and Spencer in Europe.
Yeah.
Later, William James in North America,
Right.
all kind of wrestling with this relationship between metaphysics and the sciences.
Yeah. Right. And they identified positivism as a kind of synthetic and scientifically grounded philosophy that was really focused on ordering and unifying knowledge through observation and empirical methods.
Right, right. So it's really trying to ground this ideal of unity
Right.
in a very rigorous empirical approach.
Right, exactly.
Yeah. Okay, so that brings us to the 20th century and the logical empiricists, the Vienna Circle,
Right.
which really made the unity of science a central theme of their whole philosophical project.
Yeah, absolutely. I mean, this is crucial for a philosopher to understand, right?
Yeah.
That their concept of unity of science without metaphysics was not just a descriptive claim about how science is, but it was also a normative criterion for how science should be.
Okay. So
Okay.
they had a very, very strong vision for the future of science.
Yeah, absolutely.
Right.
Right. So they aim to demarcate genuine science from what they considered to be meaningless metaphysical speculation. Right. Through a shared logical structure and a unified language that's applicable to all scientific disciplines.
Okay.
Right. Both natural and social.
Right, right. And within this kind of logical empiricist framework, different models emerged for how this unity could actually be achieved, right?
Yeah, yeah. So Carnap, for example, championed this really strong reductive approach.
Okay.
Right. So in his book, The Logical Construction of the World, right,
Yeah.
he aims for a kind of rational reconstruction of all scientific concepts based on a foundation of of elementary experiences and a rigorous logical system,
Okay.
right? So he envisions this
Yeah.
hierarchical structure where the concepts of all sciences could ultimately be reduced to the concepts of physics,
Okay.
right? So you have this unified and objective body of knowledge based on shared formal and structural properties.
Yeah. Yeah. I mean, that's a very, very ambitious
Ambitious.
vision. Yeah. Yeah. But Neurath, another key figure in the Vienna Circle, he advocated for a somewhat different, a bit more pragmatic vision of unity, right?
Yeah, yeah. So Neurath favored this more naturalistic and less formalized encyclopedia model of unity,
Okay.
right? And he contrasted this with Carnap's, what he called the system model, which he thought was a bit too idealized,
Okay.
right? He recognized the messiness of empirical reality
Yeah.
and the important role of ordinary language and the social sciences
Okay.
within this scientific enterprise.
Yeah, yeah. So he's not trying to kind of force everything into this
Right.
very, very neat, logically structured system.
Exactly. So
Yeah.
he emphasized the unity of language, particularly what he called physicalism, which is, a language centered on material things
Right.
and observable properties,
Okay.
right? And the kind of local exchange of scientific methods and findings,
So
all grounded in this anti-foundationalist perspective. Right. So for Neurath, unity was this practical tool for cooperation
right.
and for addressing complex real-world problems,
Yeah.
rather than this kind of strict logical hierarchy.
Right, right. So again, we see these different ways of trying to conceive of what unity might mean.
Right.
Yeah. Yeah. And this led to Neurath's really active promotion of this unity of science movement,
Yeah.
including, this ambitious project for an international encyclopedia of unity of science.
Right, right. I mean, driven by his socialist ideals, right?
Yeah.
And his concern for international cooperation
Yeah.
in the face of growing global tensions at the time.
Right.
He really spearheaded this movement.
Yeah.
And he saw this unified scientific understanding as essential for progress and collaboration
Right.
across different fields and nations.
Yeah, yeah. So again, this idea of unity is not just a kind of theoretical
Yeah.
or philosophical ideal.
Mm.
It has these very, very practical
Practical implications.
political implications.
Yeah, absolutely.
Yeah. Okay, so following World War II, this discussion continued to evolve with the formation of the Interscientific Discussion Group, which eventually became the Unity of Science Institute in the United States.
Right, right. So this group, which included, figures like Carnap,
Right.
Quine, and,
Yeah.
and scientists from various disciplines, they shifted the focus towards achieving consensus
Okay.
and fostering this kind of cross-fertilization of ideas and methods
Yeah.
between different fields, right?
Uh-huh.
So this era saw the rise of new interdisciplinary fields like cybernetics, molecular biology, which really reflect this emphasis on intellectual exchange
Right.
and the breakdown of these traditional disciplinary boundaries.
Right, right. So it's almost like the ideal of unity is starting to be realized
Yeah.
in these new fields
Yeah, in a way.
that are bridging these traditional divides.
Yeah.
Yeah, yeah. But as time went on, our source notes this kind of growing skepticism towards these really grand ideals of monism and reductionism.
Yeah.
And there's this increasing appreciation for pluralism
Yeah.
and interdisciplinarity, as well as this renewed critical examination of the relationship between the human and natural sciences.
Yeah. Yeah. So over the latter half of the 20th century, and into the present, historical and philosophical scholarship has increasingly kind of highlighted the complexities of scientific practice, right?
Right.
And the potential limitations and even drawbacks of rigidly imposing a unified framework.
Right, right.
Right. So the value of diverse perspectives and localized approaches has
Yeah.
gained much greater recognition.
Yeah, yeah. Okay, so I think we've traced this really, really fascinating historical development
Right.
of this idea. So let's maybe now turn our attention to the different kinds of unity that philosophers have identified. Right. And our source gives us this really, really useful set of distinctions to consider.
Yeah, yeah. So a fundamental distinction is between connective unity
Okay.
and reductive unity,
Okay.
right? So connective unity is this kind of broader, more inclusive concept
Yeah.
that encompasses various ways in which different parts of science can be related,
Right.
through shared concepts, methods, models, or even practical collaborations,
Right.
but without necessarily involving this kind of hierarchical
Right.
and asymmetric relationships that are implied by reduction,
Okay.
right? Which often assume this kind of more fundamental level of description. So think of it as different scientific disciplines kind of contributing to a larger interconnected web of knowledge.
Okay. So connective unity is more about how different fields relate to each other
Relate, yeah,
and inform each other,
yeah,
whereas reductive unity is really trying to show how
yeah.
some fields can be ultimately explained by or derived
All
from
right, reduced to
to
where.
at a more basic level. Okay, okay. And then we also have this distinction between synchronic and diachronic unity.
Right, right. So synchronic accounts, they look at unity at a particular point in time,
Okay,
right?
right.
So they examine relationships between different scientific theories or concepts
Hmm.
as they currently exist, right?
Okay,
Whereas diachronic accounts, they focus on the historical development of scientific knowledge,
okay.
right? So they're tracing genealogical connections, and often they involve these asymmetric causal or temporal relationships,
Okay.
such as, evolutionary explanations of scientific change.
Right, right. So one is kind of a snapshot of how things are, and the
Yeah.
other is really looking at the historical process
Yeah,
of development. Yeah,
exactly.
yeah. And then there's this really, really crucial division between ontological unity and epistemological unity.
Right.
And I think, for a philosopher, this is particularly illuminating.
Yeah, absolutely. So ontological unity concerns the relationships between the fundamental entities, properties, facts, right?
Yeah.
That constitute our understanding of reality.
Yeah.
Right? So it often delves into these kind of metaphysical questions about whether the world is ultimately composed of, one kind of stuff or many,
Right.
and how different levels of organization
Yeah.
relate to each other,
Right.
through holism or emergence or
Right.
reduction or whatever,
Yeah.
right? Whereas epistemological unity focuses on the unity of our knowledge about the world,
Okay.
right? So things like shared explanatory frameworks, you know,